Today, I'm really excited to introduce Dave Johnson. He's a threat intelligence advisor with Feedly. And as you can tell by his title, Next-Gen Detection, Harnessing LLMs for Sigma Rule Automation. And based on the amount of folks that have turned out here today, I think we're going to be in for a real treat.
All right, thank you very much. Hello. This is my first time presenting at a conference like this. Pretty exciting stuff. I actually came here to watch a movie. So I didn't know I was going to be presenting on LLMs. Yeah, I don't do stand-up. But anyway, you came to the right place if you're learning about detection rules and how to kind of incorporate LLMs into those pipelines. So the whole point of my talk is really just, it started from an experiment. And a long time ago, I was experimenting with ChatGPT, trying to create Sigma rules. And I'll explain what Sigma rules are too. But it got me thinking, there's got to be a better way to automate this, to create better quality detection rules at the end of this. So that's kind of the whole purpose. It's exploratory. I do have a GitHub project that you can reference and play around with the stuff I talk about in this presentation. But yeah, so if you want to watch a movie, sorely disappointed. So who am I? My name's Dave Johnson. I'm currently at Feedly, which is basically an OSINT research tool for threat intelligence, market intelligence. I'm a former FBI analyst. Half my career was with government. I used to work cybercrime, APT groups. It was really fun. And actually, I was based in Wisconsin, which is kind of a strange place to work in the FBI, but it's pretty remarkable. We had some really cool things going on. So altogether, I have about 15 years of CTI experience. And I do have a website, which is pretty poor, but if you want to check it out, it's daveinthemiddle.com. And my email is dave@feedly.com. So my whole objective in this talk is actually to keep you awake, but to also educate you about how to use LLMs, where they fit into detection rule generation, and that type of thing. And so we're going to talk about lots of different ways to use LLMs to create Sigma rules. And there's going to be a common theme throughout this presentation. It's about the quality of the input of the data. And so a lot of AI, they focus on sort of the end result, kind of the later stage of the pipelines. But really, it's about data management. And once you get the data down, you'll be able to make a lot more effective use of LLMs. And so I want you to weigh the pros and cons of each LLM strategy. There's basically three that I'm going to talk about. I talk about retrieval augmented generation, fine-tuning, prompt chaining. I'll talk about each of those strategies, what the heck they are in case you're completely new to it, and how they fit into detection rule creation. And I think an important part of this is when you're talking about detection rules, it's not just, you just ship it out and you're done. How do you validate the results? And so I'm trying to use LLMs, but also guarantee that there's some kind of quality check on it too. And I think by the end of the talk, you'll identify some opportunities where you can expand this research. This is exploratory. You can check out my GitHub project. The reference is below there. And this is a little bit of a teaser. Like if you just ran out of the theater right now, check out this repo. It's kind of fun. I just published it today. So just type in SigGen, 2 Gs. That's how I roll. So you can actually put in website URLs to threat intel reports. It will scrape the content, extract attack procedure data, and actually generate Sigma rules using an LLM. So I'll talk a little bit more about how this all fits together in a little bit too, but just a teaser if you had to walk away right now. So Sigma rules for the win. How many people have not heard of Sigma rules before? Okay, I'll go through that. So Sigma rules, in case you don't know, it is a way, so it was created by Florian Roth and Thomas Patsky in, I think, circa 2016, 2017. So, I mean, it's relatively new, and I think it grew from the frustration of learning a whole bunch of different ways to search for logs across different vendors. So Sigma rules are intended to be human-readable format to describe attack behavior in logs, and that's the real power. It's vendor neutral. There's a whole repository on the Sigma HQ repo, maintained, I think, by Florian. Never met him, but I think he's probably pretty cool. And the whole thing is it's a community where you share knowledge, and that's the intent of that repo. And I think that with LLMs, it'd be a shame to not leverage them to make detection rules and that sharing a little bit better. So I hope at least this lets you know that this is something that you can contribute to. And so really the point is, like, how do we stay ahead of attackers? That's the whole objective. How do we stay more proactive? How do we use LLMs? We've heard in the news, LLMs are creating malware. They're able to orchestrate attack campaigns. We're going to see that probably heat up a little bit more as it becomes democratized. AI models, maybe centrally controlled by OpenAI and Anthropic, but we're seeing more open source variants, people fine tuning to do bad things on LLMs. So I think we're going to see a lot more misuse, and maybe not the really large models, but smaller, more specialized models. So I think this is an important thing to focus on. So in my whole project, so I started this a few months ago, well, actually not a few months ago, half a year ago. And I just started off by just asking ChatGPT to make Sigma rules for me. And it was really hit or miss. It was terrible. It was trash. Do not recommend it unless you like trash, like that guy. So can you make Sigma rules from trash data? Of course you can, but why would you do that? It's such a waste of time, waste of effort. It's not usable. So the big thing is that in any type of Sigma rule generator, you need to have some type of validation of the input and validation of the output. So these are kind of guardrails you have on this whole, automation process. And so how would I do that? I use quality checks automatically with an LLM, and I used a scoring criteria I developed to basically have the LLM provide a score to an attack procedure going into the pipeline. So here's an example, maybe humorous. Sometimes I like my LLMs to talk dirty to me. I don't know if that's kind of a weird thing, but I had this one, I pre-prompted it with, talk to me like Dennis Reynolds from It's Always Sunny in Philadelphia, and it was mocking me. And so you can make Sigma rules very poorly if you don't have good inputs. That's the whole point of this slide. And it was making fun of me, and I kind of like that ribbing. But the whole point of this slide is to show you that if you have bad inputs, you're going to get bad outputs. Oh no, I shouldn't do stand up. So gathering a data set, that was really the first step. Like, how do I make Sigma rules? How do I get started? So it all started from basically combing through over 200 different threat intel reports. And I used an LLM to actually extract the attack procedures from the text. So I scraped a whole bunch of websites, and from 200 threat intel reports, I got about 624 attack procedures. And you might think, hey, we're off to the races, right? We got tons of procedures. They're all great. Most of them were trash because, you can describe a procedure. It might be mapped to MITRE ATT&CK, but it still might not be specific enough. It might not have the technical details you might need to be actionable. So that's what I was looking for. And so you can see in the gray text below, this is sort of the prompt I used to make sure that the extracted attack procedures were up to snuff. So, basically on a scale of 1 to 10, how does it do against all these different criteria? Is there enough context for a detection engineer to write a Sigma rule? Does the procedure address how the threat actor did the thing? If it doesn't describe how they obtained access to a server, it's not going to be overly useful. So you need some type of data input quality checks in order to create an effective Sigma rule. So I'm getting ahead of myself here. So I got this data set, and now I have a really good set of procedures. About a third of them were usable. So I have 183, roughly 200 different procedures I was ready to make Sigma rules against. So how do I make the Sigma rules? That's kind of the next part of the puzzle. I have all this data, and then how do I do the thing? So there's different ways to use LLMs in order to create a desired output. And so you probably heard this in the news if you follow LLMs. It's RAG, it's Retrieval Augmented Generation. I'll talk about what that is. I use another technique called prompt chaining. And then at the end of the presentation, I'll talk about fine tuning. And some people think that's the panacea of using LLMs. You fine tune it against your data, and then you're off to the races again, right? It can be kind of difficult, and that's actually where I failed in this whole giant experiment. I'll talk about why in a little bit too. So the first method is on few-shot prompting and RAG. So RAG goes with this idea of few-shot prompting, and all that is if you heard about this in LLMs, it's really, you're asking, it's like the LLM is a generally knowledgeable person across tons of different data. And so it has no prior training to the specific task at hand. So what you do is you kind of preempt it with some examples, and we call those shots. So like, for example, 3 + 3 = 6, 5 + 5 = 10. And so to build on that, you ask it what 2 + 2 is, and it knows that you're asking it to add. This is a very simple example, but in the context of Sigma rules, you're basically giving it really good examples to draw from in order to make a very good Sigma rule. So in order to do this, you're selecting examples, but you also have to tell it what to do and how to create the Sigma rule in the first place. So there's a lot of good resources. The official rule creation guide by Florian provides a really good template and set of instructions on how to create a Sigma rule. And actually in the template guidance, it says the best way to do it is actually use a prior example and build upon that. And this is kind of what that does. It uses this retrieval, this few-shot prompting technique, to select good examples of Sigma rules to feed into this pipeline. So what we're trying to do here is, with a good set of instructions, you do some quality assurance. You force the LLM to think. So like that's also a common theme in all these different approaches, is that you want to have the LLM think through logically what to do, like a human being would. The more descriptive you are, the more logical you are, the better the results generally are. And so I do quality assurance checks and provide 2 to 3 known good examples of Sigma rules. And then the other requirement is that you have to have an LLM with a large context window. And that's kind of like its memory, like how much can it retain in the prompt that you're providing. So if your LLM can only know like 10 words at a time, it's not going to understand even one single Sigma rule. So I talked about few-shot prompting and creating the instructions, but then there's this whole thing about RAG, and you hear about that all the time. It's Retrieval Augmented Generation. So this is how I'm selecting the examples, and what I did was I selected the very best examples from the Sigma HQ repo. So what I did was I downloaded all the Sigma rules from the repo and used that as a database and did this embedding-based similarity search. So what that means is if you ask a question about how to make a Sigma rule based on this, it will take all those words and look them up in this embedding layer in order to figure out what rules would go along with that. So RAG selects the best rules to pull into the prompt. I think this will make a little bit more sense as I go along too. So altogether, and I do have movie references because it is a movie theater. I thought it was quite fitting. And you don't see enough Matrix references too. And I'm very disappointed by that because it was a very good movie. And I love Keanu, I think everyone does. But I think RAG really kind of aligns with the Matrix, where he's learning Kung Fu. He gets all the knowledge basically injected into his brain so that he masters Kung Fu. So it's kind of the same thing. It's kind of a bad analogy, I guess. But that's what you're doing with RAG. You're selecting the best examples and you're sticking it in your brain in order to make Sigma rules. Not quite as good as Kung Fu, but it might help with adversaries. And that kind of goes with the few-shot prompting thing I talked about too. They go hand in hand, peanut butter and jelly. So how did I do this? So remember, I had to basically give it some context. This is what you're going to do. So this is sort of a shortened version of the instructions I gave it. You basically tell it who they're supposed to be, who the LLM's supposed to be. You give it a role. That's a good practice. And then you tell it like what to expect in the rest of the prompt. And that's what I have in red. You will be shown a set of good Sigma rules as examples. Instead of trying to come up with this on its own, you'll be shown a good set of Sigma rules that align with the attack procedure that you're feeding into it. So I think that's a super key point there. The thing at the bottom too, you'll notice I have in brackets evaluation criteria, and that's to make sure that the Sigma rules meet a certain quality threshold. And I love this QA test. I build this into basically every step in my pipeline because the results are way more consistent. And so the evaluation criteria, you saw that in brackets here at the bottom. That's actually broken up into a few questions. Is the rule specific? Does it address something that's a known threat or vulnerability? Can it be applied across different environments without modification? Have you made a good rule like minimize false positives and negatives? And is the rule compatible with the log source? And that's another key aspect of this too. And if I were to do it over again, I would have specified and paid more attention to the original log sources. So there's a difference between endpoint logs, security logs, and then what you find on the network. So I think if you build any kind of pipeline with this, giving it a little bit of context about your logging environment, your current gaps, what you can log only, can help a lot too. So you see at the bottom, after the evaluation criteria, I have a placeholder I use for the RAG examples, and this is what's injected, like in Keanu Reeves in his brain. So I have this kind of like notation here where I use evaluation criteria like HTML tags. That's a really good practice for me that I noticed helps a lot. And I was inspired by, I think, Anthropic's examples they have online. They have some prompt generation guidelines, and that is really a good source of reference material. Okay, so yeah, people are awake, I think. That's good. So the second method is prompt chaining. So the first one, I think that was the beast. That takes, RAG and all that stuff can be a little bit complicated. Prompt chaining is a little bit more straightforward. And so what is prompt chaining? You just kind of think about prompt chaining as you're basically asking, you're breaking up a complex action, like creating a Sigma rule, up into very logical steps. And what you do is once you do that, you create a prompt for every single step, and you feed the output from the previous ones into the next one. So, and then you basically build the entire Sigma rule at the end with the outputs of all this kind of like chained prompt and response. So here's an example. You have a procedure. You might want to identify, here's an attack procedure. What are the kind of key indicators you would look for as a detection engineer? Once you have that, then based on the procedure and the key indicators, what log sources, what category of log source would that go with? So you're breaking the problem down so that you're forcing the LLM to think through every single step. And so you're going to get something that's way more consistent at the end. So Doctor Who reference now. It's not a movie. Well, I guess he has movies. Well, David Tennant. This is the other character, and I'm aligning him with prompt chaining because the doctor kind of like thinks through things very logically, and he's able to come out at the end every time very consistent in surviving or regenerating. So the pros and cons of prompt chaining is that it's great. You're getting consistent results for the most part. You're thinking through each step. You require less data up front and less compute than fine tuning. It's potentially more flexible and adaptable than the technique before that I talked about with the few shot prompting, because you're thinking way more logically. You're filtering the results as you get through the pipeline. The drawbacks are pretty big, in my opinion. So you might get consistent results, but the inference time, that's the time it takes to get a result back once you ask the question. It took about 90 seconds per Sigma rule, which was quite a bit of time. So if you're trying to scale this, it could be very difficult to do. And this could be also fairly expensive because if you remember, you have all these different steps. those are different tokens you're sharing with the LLM when you're trying to invoke it. So token use is usually how you get charged by these providers. So if you're using a large number of tokens, it could cost a lot of money potentially. All right, so the last one I'll talk about is fine tuning. This is my biggest failure in this whole thing, most expensive failure. So people think of fine tuning as the panacea of large language models. You should fine tune on your own data, your own internal data. Maybe not, because it is an expensive experiment to try. So I did this, I used my own money. It cost me the first time $30 to fine tune based on the data set I created. And the data set I made was I took the Sigma HQ repo and I used that as sort of the output. So you have question answer pairs, you build that list, and that's your database for fine tuning. And so for the question, I would take the title and rephrase that in the form of a question and then pair that up with the respective Sigma rule. So I thought, hey, I'm super clever. I got the whole repo in here. Everything is great. But you'll see in a little second, it's a little bit flawed. So why would you consider fine tuning? And it's because you really have something very specialized, and maybe you want the output to be very consistent every single time with less prompting, less tokens. So that's one really good reason to do it. And another really good reason to do it is if you have an abundance of really good data. You don't have to have a ton of data like you would to pre-train a full LLM, but for fine tuning, you can get away with a much smaller sample. The problem is data quality is still an issue. If you have bad data, say some of the Sigma rules aren't quite as good, they're more experimental, then you're training it on potentially bad data. So there's some Q&A to do, and there's other things you can do too to make fine tuning better. I'll talk about that later. So this is Q from James Bond. I used the original because no other Qs exist in my mind. So fine tuning, the process was collecting the data set. I talked about that, pre-processing, creating those input-output pairs to fine tune the model. And then what you do is actually use the fine-tuned model against unseen data, and you call that a validation data set. So here's another way of condensing all this boring text. You have this process. I collected data that's publicly available, great project on GitHub, Sigma HQ, check it out. You format the data set, you split it into a train versus test data set. So typically you do 80-20 splits, 80% training, 20% test. And then you set some parameters in how to do the fine tuning, and that's learning rate, batch size. These are hyperparameters. You use that for deep learning. And then you actually run the fine tuning job. So here's kind of the results. So typically a training loss below 1 is good, but if it's too low, you might start to question things, especially when the validation loss is higher than the training loss. So this could potentially indicate I did overfitting, which means that when I fine-tuned it, the whole fine-tuning process caused the LLM to basically memorize my data and not learn how to apply it to external data. But a validation loss was still fairly low. Below 1 is good still, and this is not unusual. Things I could change potentially are the learning rate. So that's how, when you do fine tuning, this is how much the process corrects for errors. And so if you have too big of a learning rate, you might step over something and not get optimal results. Batch size is also something you can play with. I'm not going to make this about deep learning. I'm sorry, going too in depth here. So yeah, so you got all those methods. I tried 3. I also tried a 4th one, which is zero-shot prompting, which is you just ask it to make a Sigma rule. You just give it the instructions, and sometimes that works, but not super consistent. It's definitely one of the easiest things to do. But I want to go complicated because I'm talking here, right? So I had all these Sigma rules I created through these 3 different techniques. So recap, I created these procedures. I have about 200 of them. For each of the 200, I used each of these 3 different techniques and created their own Sigma rules. So how do I know where I was? Which one was better? So I created this meta prompt, basically to evaluate the Sigma rules on precision, real-world applicability, and alignment with the procedure and input. So precision is how you just ask it, how precise and specific the Sigma rule is in targeting the intended malicious behavior. Consider false positives. I think that's pretty self-explanatory. And a thing I think a lot of people don't realize is you really have to underscore real-world applicability in these applications because if it's super theoretical, no one has the logs for it, but it is possible if you magically have logs. It's not going to be super useful. So is it something you can apply in real-world SOC environments? Alignment with the attack procedure. So you create this Sigma rule, and at the end, is it looking for something else? Did it get so lost in translation that it's looking for something completely different? So I wanted to account for that too. Is it aligned with the input? And so what I did was I basically scored 1 to 10 on each of these criteria: precision, real-world applicability, and alignment with the procedure. And I averaged them together, created a numeric score, 1 to 10. Pretty simple. I used to do statistics and then I forgot it all, so probably not the most robust thing ever. So this is mean scores, average scores for all of the Sigma rules I created. So for method 1, I got a 8.09. And method 2 was prompt chaining, which is 7.84, and then fine tuning was at the bottom. So you might think, hey, RAG, few shot prompting, that's the way to go. But there's a little bit more to this story. When you look at the consistency and, so accounting for the highest of the highs and lowest of the lows, prompt chaining was most consistent because that was forcing the LLM to think very methodically about each step and how an analyst would actually create a Sigma rule. But RAG was generally more consistent for high quality rules, this is why I put it in green. Fine tuning was an epic failure. It cost me probably $60 in running fine tuning jobs. I tried it once by accident and it cost me $30 and oh, that was a little painful. And then the next time I know what I'm doing, and it turned out I didn't know what I was doing. And then the third time is okay, here we go. Here's the college try. But there's things definitely to improve in that too. So why would you choose RAG? RAG, I think, is kind of medium complexity. It's not terrible to implement, but you have to think about where you store the data for the Sigma rules to reference to pull into the RAG system. So that's retrieval. It's a retrieval problem. You can store the entire vector embedding in memory, potentially. You can store it in a database. You might need a way to update that consistently. The real cool reason to use RAG is that it can account for newer activity a little bit easier because you might have new contributions to the Sigma rule project, and you can pull those in as examples for novel attacks, which makes it pretty cool, as long as you update that database. Why would you use prompt chaining? Well, it's easier than RAG. If you want to get started, just think about the problem and break it up into different steps. And you can get some pretty consistently good results within reason. You have to make sure that the inputs always are valid and good. So cost might be a consideration, and scalability might be an issue just because it takes a long time to get the results back because you're sending data through multiple steps in the pipeline, and it uses a lot of tokens, and also hurts the wallet a little bit too. I'm not going to tell you how much money I put into this. It was a passion project. Fine tuning. And I'm not discounting fine tuning at all. I think there is a lot of potential here. And the biggest drawback I had was I used fine tuning on ChatGPT 3.5 Turbo. And so the problem is that I used more capable, more mature models than that for my other tests. But to fine tune, cost effectively, I only had access to 3.5. So that's something to change, I think, to upgrade that as well. But fine tuning in the long run, I think can save a lot of money. It takes initial investment. You're spending the time curating data, making sure that's good, good data engineering. But once you're up and running with fine tuning, it can be incredibly efficient and much faster. So, conclusion and future direction. So this is kind of my last slide. Well, I've got a couple more, but this is, talking about the differences between these techniques. In gray, you'll find that every method will improve based on having a more powerful model to use. So we're seeing open source, Llama 3, Meta's coming out with great stuff. Like everyone's coming out with really good models, hopefully more open source that more people can leverage, keep their data private. And then you can also use an LLM specifically trained on security data. So it will know more about the ins and outs, not be a generalist so much. So that can make it powerful too on each of these methods. But in green is how each of these methods are a little bit different in how you improve them. So you can evaluate different prompts for few-shot prompting. You can try different retrieval strategies. Meta also released FAISS, which is a more efficient vector search capability. That's something that can be very effective, has some really cool bells and whistles to try. For prompt chaining, it really just comes down to using better prompts and maybe combining prompt chaining with RAG. What if you had a sequence of different instructions and then you inject really good Sigma rule examples in there too? You could do a hybrid approach that could help things as well. For fine tuning, I think if I were to do it again and had a little bit more money, I would explore different hyperparameters, making sure that I try different things. You can change, for example, the learning rate so that it is not so big every single iteration. You can reduce that over time. And I would also include a more diverse security data set. So including threat intel reports, for example. I think that would be a good way to improve that data set. So by now, most people are awake, okay. By now you should have learned all these things. So hopefully you know a little bit more about different ways to use LLMs to create Sigma rules, pros and cons of different strategies. You learned what a Sigma rule is, hopefully some people, for the win. And opportunities for future research. And that's really what this whole thing is about, get more people interested in open source projects. I just released this morning. I stayed up late because I tried to Dockerize it, make it easy for people to install, but SigGen, check it out. And if you want to contribute to the project, I'm more than willing to collaborate with anybody, because I think when we're putting our minds together, we come up with some really cool things. And here's another screenshot of the tool if you want to play with it. That's it. That's all I got.
Thank you, Dave. We've got some great questions coming in here, folks. And don't forget, you can go ahead and add them at bsidessf.org/QN, as in Nancy A. Dave, do you think LLMs are effective for writing other kinds of detection rules aside from Sigma, like writing Python rules in a tool like Panther or SQL queries?
I think so. It depends on the strategy you're going to use. If you're going to use RAG, then you need to have that document database that has good examples. But assuming you can have good examples, you can use RAG. You can also use prompt chaining and just think through the different sequences of how you would do that normally. Break it down into a series of different prompts, and you can get some pretty good results.
I think you're on a, not your laptop, but there were several folks that were wondering, do you have any entirely LLM AI-generated Sigma rules that you could show us?
Not yet, no.
Okay, no worries. Let's see, we got a couple more here, folks. Mohammed had a good question. Is there a practical need to automate Sigma rule creation? Like, how often are organizations creating new rules?
Sure. So that's a great question. I think it's about responding to threats and keeping as proactive as possible. So sometimes I did incident response before, and sometimes you're asked to look for something immediately, and like yesterday. So this will help people get closer to what they need to look for, maybe explore things they haven't considered, and you can take that and get your detection faster. And I think that's what it's all about.
Here's another one. What are the advantages of utilizing a vector database over directly embedding examples into the prompt for retrieval augmented generation models like RAG?
Can you repeat that again?
Sure. What are the advantages of utilizing a vector database over directly embedding examples into the prompt for retrieval augmented generation models like RAG?
Yeah, so the advantage is that you take that prompt and you're automatically, so you have this embedding layer. And so you take, when you're looking at a vector database of embeddings, you take, it could be words, it could be sentences, and then you create like the mathematical approximation in an embedding layer. So if you have something that's a little bit different than the keyword, then you're still pulling that relevant sigma rule. And it's better because it's more adaptive, I think.
Okay, yeah. Perfect. Question from Matthew. Matthew, you still here? Perfect. Okay, now you've got a name and a face. Have you researched LLM performance at correctly generating valid Stix 2.1 bundles? Relatedly, how do the major LLM models perform at modeling with attack from MITRE ATT&CK framework?
So they align with attack very well, in my opinion. For Stix bundles, I haven't tried that, but I have tried Atomic Red Team, which that's kind of like the other end of this. How do you, before I was going to explore how do you create the logs, and I was going to use Atomic Red Team, and I got into that and like, oh, this is going to take too much time, but that's another thing to try too. So
okay, thank you. And thank you, Matthew, for the question. In your prompt chaining flowchart, why isn't the flow strictly sequential? Under what conditions do you skip steps in the flowchart?
Yeah, so for certain questions, you might want to have the outputs of two different prompts or maybe just one prompt because you want to, you're retrieving a lot of valuable data and not all of it needs to be used at every single kink in the chain or every single link. So I had some very complex conditional logic set up in the app. So I would take inputs from a couple different things, but maybe not one. So it's about efficiency. That's really what it comes down to.
Okay. Home stretch here. Anybody want to ask questions? Throw them into Slido here. What document database did you try? Which one did you end up choosing and why? Yeah,
so I use ChromaDB. It's open source. And I think I knew the most about that than any other one. So it was, I saw like example code, like which one should I use? And that was the one I picked.
Easy peasy, yeah, when you do it that way. And last question, unless anybody has any others to throw out. Did you only use LLMs to generate the final scores? Or did you, or other humans, also score them? Like, how did you know when you can trust LLMs for scoring results?
Yeah, that's a great question. This is part of exploratory research, and I only had time to spot check a few Sigma rules that were created this way. And then I used the sort of that meta prompt to make, the broad sweeping, quick quality check. So that's definitely something that we can work on.
Okay. Well, thank you for your presentation. We've got a gift here from Socket Security, our friends over there. Wanted to make sure that all presenters go away with our gratitude, because this is a lot to come out here. More than 300 folks vying for just 100 slots to be able to speak this weekend, ladies and gentlemen. Dave Johnson with Feedly.
All right.
Thank you so much.
Thanks.